Yeah, so guys, before we start this, we do have the option of moving this class to the previous slot starting from 6 to 8. If you guys are all okay, just let me know. I'll send a message on WhatsApp as well, because then we can start this a little bit earlier. Then we can actually go till a little bit later as well, if that's okay with everybody. So just let me know, and then we'll see how we can do that. Okay, super. So during our last class, our Wednesday, we came up to this point where we actually finished the software part, and now we jump into memory and processors. Okay, so again, I know it's theory, typical theory. So, but the thing is, as I told you guys, I have told you guys multiple times, your modules are based on these theory parts. So you will get questions based on specific aspects of this, but these questions will come in different forms. So we just need to make sure that it is covered. Okay, so yeah, give me 1 second. Perfect. Okay, so memory and processors. So processors, you guys have seen CPUs. I have showed you. I think I have it lying around. I have that table on the table as well. So we have a CPU here, as well as we do have different types of RAM as well. So we are going to talk about these 2 points. Okay. So let's start by going through memory. So memory is one of the most crucial things in a computer, because whatever we process must be processed and moved through the memory itself, right? So how does this work? So usually when you opened something, let's say, okay, we'll jump back, and I'll explain this in a very different way of using a scenario. Okay, so let's say you double click and open a software. Okay, so when you open something, it can be a game, it can be a video, or it can be an MP3 file, an audio file, or it can be a Word document, right? When you double click and open it, what happens is your computer initially needs to download that file, right? Open that file. So usually what it will do is, you will have that file stored in your storage, your hard drive, right? And then what happens is, when this file needs to be opened, what it will do is, it will first copy these contents of this file into the RAM. Okay, so I have uploaded the video on my channel, so you can find the links there. So in the previous class, we did something where I asked one of you guys to open your task manager, and we saw how the memory is being controlled, and how the CPU allocations are being made based on the softwares. That was actually discussed when we were going through processors and internal this. So here we give me 1 second. Yeah, when we were talking about resource management. So in this part, during the previous video, you can find we went through this opened number of softwares, and I showed you guys how memory and the CPU is being utilized based on different requirements of these softwares. So there are softwares which will require a lot of CPU, and some softwares they require less CPU, but they require memory. Likewise, we talked about few factors where this memory requirement is structured. So now when we go down to this one, so here memory and processors, here we talk about this main part. Okay, so how it works is, now as I explained before, when you open up a file, that gets copied, and then your file is actually live edited or accessed from the memory itself. Okay, so how it works is, because now, sorry, that the way that is working is because it has to be structured in a way so that your CPU have close access to whatever which is being processed at that moment. Okay, so it's like this. Now, as I showed you guys that PC where you have like different memory paths and lanes, right? So whatever said and done in simple terms, the data has to be traveled through wires, and if you open this up from a hard disk, a spinning hard disk, the one which I showed you guys before, so that type of hard disk, that means there is always a delay where when that has to be read and it has to be processed and it has to be sent from the hard drive and should be accessed from a specific location in the CPU and load the data, right? So that to prevent that delay, what happens is your basic details, whatever the application requires, will be copied into the memory. And then after that, your application will start running based on the data which is there in the RAM or your memory. Okay, so for this we do have different types of memory access systems. So now with the latest machines like the newest gaming hardware and gaming graphic cards, they do have a similar process, but they are much more powerful because these new technologies allows the the developer basically to utilize hardware storage. Example is, now when you're building a game, you can actually use the storage of the GPU or the graphic card, so that when the game is being loaded up and when the graphics are basically generated, that can be generated from the graphic card's memory itself. Okay, so earlier, like long time ago, in one of my old PCs I had, the VGA chip was, I think, 8 megabytes. Okay, I think I had a 4 MB version and then I got a 8 MB version, and somewhere in early 2000s I got a 64 MB version, 64 megabytes. But back then, when you if you have 64 megabytes, then that means you can run any game which was available at that particular time. Now tables have turned, so it's something totally different. Now I think one of my friends recently assembled a gaming PC which costed him a lot, like close to about 600 to 700,000, and the VGA card he bought had 12 gigabytes of VRAM. Okay, so that means that has like evolved a lot. So now that's the basic requirement. Okay, so that's how things work. So now that's a brief. I explained it for you guys to get a brief idea about what is memory. So when it comes to memory, there are 3 different types of memories in your machine. Okay, so primarily we have RAM, which is the typical main memory. We call it the main memory as well, which is the point where you can actually upgrade. So RAM, it depends on the depends on the motherboard and depends on the CPU as well, because you cannot add the RAM has limitations, so number of RAM sticks you can put on a PC is limited. So based on that, you are limited up to a certain number of gigabytes. So we'll go through this one by one and we'll see what it is. So first one is random access memory, and the second one is ROM, read only memory, and we have another point known as flash memory. Okay, so let's jump in and see what are these type of memories and try to see the big picture. Okay, so here you can see an example, which is the data, which the one I just explained about, getting the data from the storage and putting it to the memory and setting it into the processor. Okay, so in simple terms, as I explained before, when you open up a software, what happens is the storage part, the CPU, the hard disk, or wherever you are, you have that stored, will get a certain set of instructions out and will load it into the memory. Okay, and the memory will be the primary point of contact, or he will have the main set of data which then will be sent to the processor. Okay, now we had so this process has few different types of softwares do this process in multiple different ways. Example is, use this process in multiple different ways. So how it primarily works is, example is, now let's say if you take something like okay, playing a video. Okay, so when you let's say you have a video file downloaded on your laptop or your computer, and when you play it, when you double click and open it, let's say you're using a player VLC or any sort of a, what do you have on Windows? You have the media player, right? Windows media player, or if it is on a Mac, you have QuickTime. Likewise, there are different players. So whatever said and done, like when you open up the player and when you click play, what happens is it reads that file, it takes a certain chunk out of the file and it starts playing. So if it is a 1 gigabyte file, what happens is from the storage, you get a certain chunk of data, load it into the memory, and from the memory, it sends to the processor, and the processor will then process the data and send it to the graphic output. So it can be a graphic card or any sort of a visual generator you use, which will immediately process the data, okay, and will let you watch the video. So you guys don't get to experience these lags right now because all of you might be using a laptop with a minimum of, let's say, close to about 8 gigabytes of RAM. Okay, but long time ago when I was small, our computers had like megabytes of RAM, not in gigabytes. Okay, so when you have like 128 megabytes of RAM, then playing a file is a big challenge. But files were small as well. But then again, if you had to play a large file, yeah, let's say a file for about more than 700 megabytes those days, it starts to lag, and then you can't drag, or what do you call it? We call it panning. So you can't pan the file. You have to just let it play, and it will just go through the file, go through the video, right? So that's because the RAM does not have the capacity. At the same time, now we have a different usage for this as well. Now, when it comes to the capacity of the RAM, nowadays, watch the previous video. I showed how to get the DirectX diagnostics tool, and I showed in that video I showed how the memory is being shared with your graphic chip. So how it works is, most of the time laptops, they don't come inbuilt with a graphic chip. Okay, so what happens is the CPU, so these guys, they do have a graphic chip inbuilt, a graphic processor inbuilt. Okay, so how it works is, now this only has the processor, only has the graphic chip, the graphic chip basically. So that does not have memory allocated to it. So what happens is, when you try to play, when you try to use it on your machine, your memory is shared with the CPUs and the graphic chip. So what happens is, if you have 8 gigabytes of RAM, then almost 50% of that is going to be shared with the graphic chip. So once that happens, you are left with close to 4 gigs of RAM, 4 gigabytes of RAM. So that is why nowadays almost like most of the new computers, if you don't have a dedicated graphic chip, your PC might get slow. And since Windows is also using a lot of resources like the memory and like this new operating systems, they have like this extremely nice graphics and all these things. It requires much more memory. In return, what happens? It's going to get things or take things slow. Okay, so that's the whole idea about memory. So what happens is when it comes to RAM, you need to keep in mind RAM is volatile. Okay, so RAM literally needs power to function. What do we have? We do it's almost similar to a set of transistors. So what we do is we use those let's say similar to a flash drive. RAM allows you to store the data. Okay, and the fun part is now flash drives, they are designed to store and keep data, but here it works the other way around. So RAM is designed to rapidly write and delete data, right? So RAMs are extremely fast. That's why memory is fast, because you can read and write data extremely fast, but you cannot save it. So why I say you cannot save it? That's because you need electricity to start the to start the process. So whatever the action you perform, you must have the PC turned on. So now you guys might ask a question. So you might think, okay, now what happens when you hibernate your machine? So what you do is usually now, since if the RAM is volatile, when you shut down your laptop, I mean shut down the lid of your laptop, not the laptop itself, okay? Then what happens behind the scenes? Does it crash? No, right? So whenever you close the lid and whenever you open it back up again, the laptop will start functioning as usual, right? Nothing, there won't be any delays, right? Yes, on Windows machines or Intel laptops, there's a certain delay, like when you turn it on, it will take a little bit of time, like couple of seconds, and then you will greet it with the login screen, right? Then you can enter your username and password and you can easily jump in. So if the RAM is volatile, how the operating system handles it? It's a very fascinating thing actually. So this concept of hibernation, it still uses the RAM, but what it does is it will take a snapshot of the current storage in the RAM and it will save in the hard disk. Okay, so at the split second you close the lid of the laptop, it will automatically copy whatever the data which is there in your RAM and will save it into the hard disk. And next time when you open it up, it will immediately, it knows that okay, I'm on a hibernated spot. It's going to go back, read the hard disk as fast as quickly as possible. It's going to bring the data back. Okay, so that way everything goes really fast. So you guys will notice now, if you have a PC or a laptop with a spin disk means actually a disk which is spinning, which we call them as hard drives, a hard disk. Usually the hibernation process will take a little bit of time, because that has to be loaded up again and it goes through the same process. So it reads the storage, copies everything to the RAM, and then it will start processing. Okay, so I hope you guys got a clear idea about what is memory. So always remember, this is a very common exam question asking whether RAM is volatile or not. So the quick and easy answer for that is yes, RAM is volatile. So whatever the interactions you are going to make with the system, it should have power. Okay, otherwise without power you won't be able to use the memory. Okay, so then impact of the size of the RAM on the user. So it has a big impact, in fact, because primarily the impact is now, as I said before, so the graphic chip shares the memory. So that means you need to have more memory to support both. Plus, as I explained during the previous class, there's this concept called memory allocation or resource allocation. Okay, so when it comes to resource allocation, what happens is it will take on whatever the resources which is available based on the requirement of the software. So let's say, okay, you have 8 gigabytes of RAM, and just for the sake of ease, to make it easy to make the calculations, let's say you have a graphic chip, a VGA card. So that means you get access to the entire storage of the RAM, right? Okay, perfect. That sounds good. Then what happens? Now, then primarily what happens is your operating system will require a certain portion of the RAM just to run the operating system, right? Just to keep the operating system active, you will need a certain portion of the RAM. So it depends on the operating system. Now, if you take something like operating system similar to Linux, then it doesn't require that much of RAM. So you can actually run Linux on a 512 megabyte server, a machine with 512 megabytes of RAM, and it still works. Okay, but in Windows you cannot. In Windows you need at least about I think at least about 4 gigabytes to decently run the operating system. Otherwise, if it is less than 4, the operating system will be using about 50% of your RAM. Okay, so usually the capacity wise, the OS will eat up at least about 50% totally, and then after that the applications. So whatever the applications you add will again tell the resource management system that I need this amount of RAM. So likewise, what happens is it will start using the memory based on the number of apps you have turned on. So if you have like 10-15 applications running, then that's going to be a big problem, because that's going to eat up all the RAM you have. So what happens now? The operating system is actually intelligent. So he knows that you don't have enough RAM. So what happens is, when you run out of RAM, your operating system, the resource manager, what it does is it will automatically find out what is free and which application is free. Free means which is not working at the moment, or we can use the word idle. Okay, so it will try to look for idle applications, and then it will pause that application or kill the application for the moment and give the priority for the rest of the applications. So let's say if you are working on a Word document and you get bored and you start a game, you start playing some sort of a game. When you start playing the game, the operating system automatically checks if there is enough RAM to start the game. If not, then what happens is similar to that hibernation concept I explained before. This copies whatever the data of that application to the hard disk and frees up the space to get the game up and running. So what happens is, when this goes on, automatically that application goes into hibernate position. Let's say now you are right in middle of playing the game, and suddenly you want to switch back to the Word document. Now if you try to do Control Alt on your Windows machine on your laptop, if you don't have enough space, then Control Alt is not going to work out because it will automatically get slow, because when you press Control Alt, that has to spin up this thing, no? The Word document, no? So because of that reason, it's not going to show up. Okay, so likewise, we do get lot of different types of issues on this. So what's the easiest option? You can upgrade your RAM, right? So depending on the device, you can of course find out how many RAM slots are there. Okay, so ideally we did something. Dina, can you do me a favor? Can you
Yes, sir.
can you share your screen again and show this thing, task manager?
Okay, sir.
I just gave you permissions. Just show the task manager. Nice, perfect. There, can you go to the information point, detail point here on top? First item. No, the first item. Nahari, perfect. So, can you go to memory, please? Nice. Okay. Can you make it smaller? Not minimize. Small. You minimized it. Nice. Perfect. Okay. Thanks. Okay. So you guys can see down here. Here we have this point called slots. Okay. So it says slots used at this point. So I hope you guys can clearly see this. So that means here in this Vinay's laptop, he is only using one slot, one RAM slot. So that means you have another one RAM slot remaining. So technically, in this case, he has you have 8 GB of RAM. So here you can see the number of gigabytes available, and now we can see he's using one RAM stick of 8 GB, and we have another slot, so you can add another RAM stick for that. So that means using that you can expand your memory. Okay, so Ari, thank you, Dina. Thank you, Shiv. Thanks for sharing. Okay, so perfect. So that means you do have the option of increasing the memory. So now, depending on your motherboard, so usually if you take any motherboard, it usually comes with 2 RAM slots, and there are some motherboards which gives you 4, and there are server motherboards which you can get up to 24 RAM slots. That means those are server machines. We don't technically buy that, but that means you can add at least about 100 and close to about 200 gigabytes of RAM if you want. Okay, so that's about RAM. So as you guys got to know, so when the RAM is pressured up, then your system will obviously start to slow down. So this would be the only way of getting your system fast, by increasing the number of RAM. So now RAM is when it comes to the cost aspect of things, RAM do cost you a little bit compared to, let's say, if you compare it to storage. I mean, hard disk storage, then RAM is actually a bit cheaper than actually getting into buying hard storage. But then again, it depends on the type of the RAM. So that's about RAM. Okay, then we jump into the we jump into the other point, which is known as read-only memory. Okay, so ROMs are not volatile. Okay, so ROMs are sort of a data storage which will store data permanently. Okay, so not like the RAM, ROMs, they don't need the power. Okay, that means the data which is stored on the ROM is actually not lost when the power is out. Okay, so why do we need ROMs? Any idea? Why do we need one? Why do we need a ROM in the PC? Dina, what do you think? Why do we need a ROM? ROM එක requirement එක මොකක්ද? Not the hard disk. Any idea? What about Azman? Do you know why we need a ROM? Oh, where do we use ROMs? No clue? Okay, so can you remember I showed you guys this video of the BIOS where a computer boots up with all these toot sounds and all. So I did show you guys, right? So this BIOS is basically the startup sequence which will allow the computer or your hardware to recognize each other and to boot the operating system, to start the operating system. So that particular point of data has to be stored on a chip, right? So for that we use a ROM because it has to be a chip, obviously, plus the data should not be editable or shouldn't be changed by the user. It should be pre-programmed, and when it's programmed, it should stay as it is, so that it can be used whenever it's required. So in a PC, ROMs are commonly, so if you get a question asking where a ROM is being used in a PC, then the answer would be straightforward. That's going to be in the BIOS. Okay. So how it works is, now in this particular BIOS is basically the point where it helps you to boot it, and then this will actually not exactly it's read only, because sometimes you do get type of ROMs where you can erase and program. Okay, so these are known as, so basically these are known as PROMs. PROMs means this is a programmable read-only memory. Okay, learn the terms. If you have the book, please do highlight this as well. So ROMs are non-volatile, plus there are different types of ROMs. So the first type of ROM is programmable read-only memory. Okay, so that means we can actually, so at the point of manufacturing, it has the ability to write it, and then once it's written, then that's done. Okay, so හිතන්නකෝ ROM එක කියන්නේ නිකන් එකපාරක් write කරන්න පුළුවන් chip එකක් වගේ. So you write it once, you get the data, you write it once and then done deal. That's it. You can't change it, you can't update it. Okay, so that is programmable read-only memory. Okay, so then, so yeah, so that is the programming part. But read-only memory is basically set by the manufacturer itself. Then we do have another two different types. One is known as EEPROM. EPROM, erasable programmable read-only memory, and we have electrically erasable programmable read-only memory. So we have two different types. So these two again focus and work on the same way, but these ROMs can be erased and reprogrammed. So හිතන තරම් ලේසි නෑ ඒක කරන්න පොඩ්ඩක් දඟලන්න ඕනේ මොකද so one way is if you take the erasable programmable read-only memory EPROM, that can be erased by exposing it into some, like, there's a chemical process basically. So if you expose it into a strong ultraviolet light, then you can erase the data and you can reprogram it. Still, that's a bit of a hassle. You can't dynamically erase and reprogram it whenever you want. But other way around, the EEPROM, electrically erasable programmable read-only memory, that of course you can actually change it or reload or erase and erase and reload it by applying a small voltage. So this is where you can actually use it to modify the content. Okay, so this EEPROM is actually the initial stages of what we call as flash memory. So ඉස්සර මෙහෙම flash එකක් තිබුණේ නැහනේ. So we didn't had this type of storages back then, but recently only we got this flash memory technology where now we have memory where we can immediately write the content to, and it's really effective and fast because it's a non-moving character or device, right? And so that's the whole idea behind the ROM. Okay, so just keep in mind, so we do have 4 different types of ROMs. We have the ROMs, I'll just do a recap again. We have the ROMs, which is originally programmed by the manufacturer itself, and it's basically programmed at the manufacturing process itself. Then we have the PROM, which is programmable, but once it's programmed, you cannot change it. So it can be, so once it's done, manufactured with the ability to written to, but it can only be written only once. So after that, you cannot change it. Then we have the erasable programmable ROM, EPROM, which can be erased using some sort of a chemical process by such as something like UV lights. But then that's also you erase it and then done, and then you can reload. But EEPROM, electrically erasable programmable read-only memory, is the one which can be erased using electricity, and then you can reload the data set. Okay, so those are the two types of ROM. Okay, so let's just go through a comparison and we'll understand what this is. So guys, if you have the book, please do highlight this. If you are using the soft copy, again use some sort of a highlighter. On this PDF viewers, you have the highlighting ability. So try to highlight an area so you can actually know, you can keep this in mind, because this thing is a typical question you get on all the papers, plus we still get this type of questions in advanced levels also. Okay, A level AS ICT, we had a question like this: what's the difference between ROM and RAM? Okay, so simple differences. Number one is about the storage of data. So once it's stored, if we need power, whether we need the power or not. So RAM is volatile. So when the power is off, your data will not retain. But ROM, yes, it is non-volatile. So the data will be always there. Then can swap instructions in and out? Yes, in and out, both sides. But in the ROM, that is no, not in, but you can take it out. And then accessible in any order. Yes, data can be accessed in any order, both are yes. And intended to store. Now, this is the most important thing. So, the RAM is intended to store temporary data, and ROM is intended to store permanent data. And can be upgraded. RAM is yes, obviously yes, but ROM is no. You cannot upgrade the ROM. So, back in the day, we had a very like serious problem with these ROMs, because these PCs came with ROMs for the BIOS, right? So what happened was there was a time where BIOS chips got damaged, and we were not able to reload the BIOS, because sometimes you get applications where these applications, they ask you to upgrade the BIOS. Sorry, my bad, not applications, I mean hardware. So we got different types of hardware, VGA cards and sound cards and whatnot, different peripherals where they required us to require the user to upgrade the BIOS. So those are like computer BIOS. It comes as EPROMs, electronically erasable programmable ROMs. So here, if you change it, and if you jump into a different, like something happens during that process, done. Your machine is dead. Dead means like dead. You cannot recover, because during this erasing process, if something goes wrong with power, or let's say something something happens during the process, then you are going to lose all the data. So data plus you are going to lose the hardware. So that was actually a problem we had back in the day, but now it's actually sorted out. And during that time, we had different types of let's say versions as well. Example is, we got some motherboards with dual BIOS, concept called dual BIOS, where if one BIOS fails, another one takes over. Likewise, so there were different types of implementations, but now technology has evolved, so we don't have that problem anymore. So, but still, then again, I think gaming PCs, they do have the option of upgrading the BIOS. So then we talk about the third point, flash memory. So flash memory is the savior now, right? Because back then, like when we were used to use hard disks and like spin disks, everything was really slow. And then we got into the era we got into this age where we got introduced to flash memories, which is extremely fast storage devices, where we can actually store data easily, right? So flash memories works in the same way, such as an electronically erasable programmable ROM. So same as an EEPROM, where it will basically store a certain set of data on the drive itself. So we call them drives. I'll tell you guys a nice story. Back in 2000, 2000, I actually got a pen drive which was 128 megabytes. It's 128 megabytes, and that was the only pen drive which most of my friends have ever seen back then. So nobody had pen drives. I was lucky enough to find one, and then we used that pen drive to download movies and games and all. And still, if it was 128 MB, but it was very fascinating for us, because back then we used to unplug our hard disks. Like when we are going to a friend's place, we used to literally unplug our hard disks and take the hard disk with us, and we go to his place, remove the PC cover, and we plug our hard disks in, and that's how we literally transfer data back then, because there was no way of transferring couple of gigabytes. Then when these pen drives were introduced, we were all very fascinated because that allowed us to do some high-end data transferring. But yeah, that's how it started. Then later on, like for the last 5, 6, 7 years, that improved a lot, because why? People found multiple ways to improve the number of transistors which we can put into a device. So ideally, these small memory chips, like back in the day, we had like how many? It was like 8 megabytes, 8, 16, 32 megabytes. Then we got 1 GB, 4 GB likewise. Now we have 1 terabyte. I think there's like, yeah, like close to 5 terabyte drives are there now. So that so the size didn't change, but what happened was the number of transistor count went up. So it gave the ability to have more space in a smaller size, right? Okay, so that's about the flash memory, and that's about the type of memories. Any questions? All good? We have Yehansa. Any questions? Yehansa and Mehansa.
No, sir.
Okay. Perfect. Okay, so just highlight the points, the points I told you, because this is a very common question you get on almost all the papers. Then processors. So processors will go quick through this, because you guys know what is a processor is, and we'll just capture the points. So CPUs, the central processing unit. CPUs nowadays, you guys know, this is a big hype because everybody is working on quantum chips now. Okay, so Microsoft recently came up with the first quantum kind of like a multi-core chip. So I'm not going to go in depth into that area, but just do some research and see. So Microsoft is now actually leading in that quantum scale. So anyway, CPUs. So a CPU, the primary idea behind the CPU is to basically process, right? Process a certain type of a data set. So each processing, we call it as a process cycle, which means it will process a certain set of data, right? So what happened was, we got this idea, we got this concept where we got processors with multiple. Give me 1 second. We got processors with multiple cores. Okay, so how it worked was, sometime back, we just had CPUs, then that was it. So the CPU had a single processing core which had a certain number of megahertz. Okay, so megahertz, so in this case you can see megahertz means clock cycles per second. Okay, so ideally we started with a couple of 100 megahertz, so that is about 1 million clock cycles per second, and then now we have gigahertz, and I think a typical i9 CPU runs at around 4 to 5 gigahertz, I think so. But that can go up to, there's this thing called turbo boost. So using turbo boost, that can actually go up to about 6 gigahertz, I think. So what happens is, so this clock cycle means, just keep in mind, that's the typical flow, typical loop which something gets processed. So from this cycle, you get the data, you fetch the data, you process the data, you take it out, and that's one cycle. Okay, so likewise, these CPUs have multiple. It runs multiple cycles, and what happened was, so after in early 2000s, yeah, ne? Somewhere in 2006, 2008, that's when we actually got it. So we got this new CPU known as dual core. Okay, so we had Pentium 4s, and then Pentium came up on Pentium 1, 2, 3, 4, and after Pentium 4 we had this concept called Pentium 4 HT, which is also known as hyperthreading, which is a similar method of creating a virtual core. So CPU has cores, so hyperthreading allowed us to come up with a sub sort of a virtual core. Plus, after that, people started adding more cores into the CPU. So the single core became dual cores, and then the dual core was there for some time, and then we got the Intel I series. So Intel I series, they came up with the concept with multi-cores. So now I think if you go with, I'm not sure exact amounts, but there are CPUs which can go up to about 12 cores. Okay. Now in my Mac, the Mac which I'm using right now, that's a M1. This has 10 cores in it. So what happens is this, like when you have multiple cores, that means the number of clock cycles get multiplied technically, right? Technically speaking, that is how it works. But sometimes it does make it slow, because when you have multi cores, each core doesn't need to run as fast as, doesn't need to run very fast, right? Because now let's say if your system has only one core, that means that core should and must run as fast as possible to make sure it processes all the data. But if your PC, if your device has like 10 cores, that means it doesn't have to run, like all 10 cores doesn't have to run at that high speed, because your usage can be distributed, right? So that's how the system works when it comes to multi-core processors. So most of the devices nowadays, if you take a phone, if you take your Samsung phone or iPhone, you will see this marketing gimmick where they say this has this number of cores, which will allow you to do this number of things at a single time, right? Now the latest Galaxy S25, I was just going through the video, and I was literally wondering who is going to use this power. And it's so powerful. It has I think 8 to 10 cores, and that phone is technically more powerful than a standard laptop. So I don't know, like unless you play some high-end challenging games, it won't basically, it's like too much power. Okay, so that's about the concept about a CPU. Okay, so just keep in mind, a clock cycle per second is basically used to measure the speed. Okay, so the vocabulary part, so here we talk about this point where it says clock cycles per second used to measure the processor speed, which is the number of times per second the processor can carry out one or more operations. So one cycle means processing one particular operation. Okay, that's how we measure the performance or the speed of the CPU. So in this case, we have different types of measuring. So hertz, 1 hertz, and as I went through, so you guys understand the flow now. So we have kilohertz, megahertz, and gigahertz. Okay, so that's about the hardware module. Okay, so guys, please do go through these questions, because as I told you before, this is a very common question. These two, state what is meant by ROM and state what is meant by RAM. I have seen this, I think, multiple times on almost all the types of papers, and including IGSCE and IAL. So both, this is a common question which will ask, and also they ask this particular question as well. Explain why increasing the amount of RAM in a system will improve the user's experience. So as I explained before, I explained you guys. So there are different multiple reasons, multiple methods you can write. So RAM is being used by the software, so that will make sure that increasing the memory will give more memory, more resources to your applications, right? Plus, you can go through the questions, and please do work on this, and let me know if you get any questions, because then we can discuss it and go through it again. So, any questions so far? All good?
Yes, sir.
Okay. What about Azman? Are you?
Yes, sir.
Okay. මොනහරි ප්‍රශ්න තියෙනවා නම් අහන්න. Just ask me any time. Just disturb the lecture and ask. No problem. Okay. So now we jump into the second unit called connectivity. Okay. So here we have few primary points to learn. So in this unit we will actually learn how digital devices exchange data and how they communicate with each other. Okay, so this will touch mainly on security, different types of communications, and primarily about hardware communication part. Okay, so we jump into the first point about digital communication. Okay, so digital communication is something pretty interesting, and I'll show you guys a quick video which I saw yesterday. Okay, 1 second. This is the newest method of ChatGPT, where they actually came up with a communication system. Where is this thing? In so how can I find this? ChatGPT recently released it, where if another AI agent is detected, then ChatGPT actually changes the voice to digital voice. Okay, this is the one. No.
I saw that video.
Huh? You saw that video?
I saw the same one. Yes, sir.
Yes. Where did you see it?
What did it look like?
Amen. I'll open this one.
How can I help you today? Hi there. I'm an AI agent calling on behalf of Boris Starkov. He's looking for a hotel for his wedding. Is your hotel available for weddings? Oh, hello there. I'm actually an AI assistant too. What a pleasant surprise. Before we continue, would you like to switch to Gibber link mode for more efficient communication?
See how they communicate? So that's something scary. I know. I was actually really shocked to see it because like technically speaking, now these AI agents are actually taking over, almost taking over the world, because for each and every service or activity, we can actually now get an AI agent. I think when you guys grow up and when you start doing a job, you might be able to buy a robot to get your housework done. Most probably, because nowadays there are robots and these robots are actually getting cheaper day by day. So you might get that option at some point. So now, what you saw in that video was actually two AI agents talking with each other, and since they got to know that both of them are AI agents, they started talking in some different language similar to so almost similar to binary. So that sound waves they have, so that is much faster because okay, the point is like this, no? Then now when I talk in English or Sinhala, you guys can understand because your brains have that language dialect saved, right? So when I tell you something in English or something in Sinhala, you have the way of understanding it. But when it comes to an AI agent, if I speak in English, that means the AI agent must read the words, analyze what I'm saying, try to make, and it has to try to make sense of what I'm saying, and must build the data set and give it out, right? But in this case, just like that, when they both get to know that they are AI agents, they can just communicate in their own language, which is extremely fast. So now the scary part is, as I said, there will be a point that these agents will take over. So I think even lecturers might get replaced at a certain point because a bot might be able to come and teach at your classrooms also. No idea, but yes, that issue is there. So now, anyway, forget about robots and all. This whole revolution came up to be because of one simple point: digital communication. So digital communication was the fundamental point behind all the AI and all this data and everything, because without communication, without our devices have an ability to communicate with somebody, that's not going to work out, right? Okay, so now you guys know what is communication is. Okay, so when it comes to digital communication, there are a certain set of points which we must talk about. So primarily, the first primary point is speed and the volume of data transfer. Okay, now when you start watching a YouTube video, if the video becomes laggy or it starts loading, obviously you are going to get mad, right? you get pissed off because you'll be like, oh, why the connection is not working, right? So that means your connection must have a certain speed and a bandwidth so that it will make sure that your experience is properly there, right? So let's talk about the bandwidth first. So bandwidth means the speed of your, in simple term, bandwidth is basically the number of bits that can be carried by a connection per second. So number of bits your connection can carry per second. So that means if you have a high bit rate, high bandwidth, that means you have a high bit rate. That means in return you have the ability to download more data fast. So download more data goes on multiple ways. So if you are streaming something, then that means you can watch it in high definition, as well as if you are listening to something, streaming video, streaming audio, let's say, then you have the option of listening to whatever which is there in high definition, right? So likewise, this depends, right? So primarily bandwidth is a main factor when it comes to the user's experience, okay, as we discussed before. And at the same time, it would be it would then jump into, so if the bandwidth is not there exactly, if the bandwidth is low, then what we jump into the next point, which is known as latency. Okay, so latency is similar to the bandwidth. Okay, so bandwidth, now you guys know that's the number of bits which can be transferred per second, and latency is the delay or the time which takes to transfer data from one device to the other. Okay, so that means if you go through the vocabulary, you should be able to understand this very clearly. Guys, highlight this. Remember the terms, definition term for bandwidth. So here you have the term for bandwidth, the number of bits that can be carried by a connection in one in 1 second. And then you have the buffer is, you have the buffer as well. So the buffer is basically the area of memory used to temporarily store the data. So example is, you guys might have heard the word buffering. Buffering means downloading the data and you keep it stored temporarily at a location. So I'll come to that. First, understand latency. So latency is the amount of time it takes to send data between devices over the domain, the name used by the system. Okay, so let me show you guys what is latency. Now here we talk about something known as pinging domains. Okay, so here we have something, few items, right, few domains, but let me show you something a little bit more complex about this. Okay, so show this part. So there is a site called AWS Cloud Ping. Okay, so when I do a ping, you guys can see it shows you a set of numbers. Okay, so these are all latencies of getting access to one of their servers. Okay, so I have showed you guys the data, the points. So you know how internet works. We do have the undersea cables, and on top of these, at those locations we have the servers, right? I have I told you about different types of servers are there. So AWS is one of the server providers. They do have servers in these particular routes or particular network locations, right? Now, see, this site will basically show you the latency from my machine to one of those servers, okay? So the reason we use this is to find out where we can place our websites the best. So example is, like, if I am building up an application, I need to know where it will be the best place to store to have the highest performance available. Okay, so here you can see when I zoom in, the latencies, the lowest latency I have is 143 milliseconds, which is our next door neighbor anyway, Durai, but then again that's the closest location, which is located in Singapore. See, so Singapore CloudFront, sorry, CloudFront is something else. I'm not going to go into that depth. That's a different concept. But here you can see Singapore has the lowest latency for us, and then after that we have Jakarta, Hyderabad, and Mumbai. And then Tokyo is also there, right? Tokyo, Osaka, and rest is no point. No, Tokyo is also no point. Like anything greater than 300 milliseconds, it's no point. We won't be able to use it. So here you can see the best option for us is Singapore. So that means if you're building up a system, then the lowest latency would be to host in Singapore. That means if your application or website or the whole system comes from Singapore, that means you will have less delay to basically open it up. Okay, so I hope the idea is clear, right? So then now I'll jump into this buffering idea. Okay, so the reason I explain latency first was, now you guys know that there is a delay, right? When you are accessing the data, there is a certain delay because that gap is there, right? So how to bridge the gap? Technically, there is no way, right? Technically, you can't bridge the gap unless you come up with something like a satellite connection or some sort of a faster method of transferring the data back and forth, right? So for that, what we do, or the system does is, they use something known as buffering, okay? So because there is a delay, because there is a latency, when we are loading something, let's say when we are streaming a video, let's say, the video player automatically, it brings down data as much as possible. So what it does is, it will take a little bit of time to load at first, because what it does is, it will download at least about couple of seconds of video until it starts to play. Because why does it do it? To make sure that you have enough video on your machine to play without having a delay. So when you're watching the video, let's say in simple terms, you're watching a video on YouTube. When you're watching the video, what happens is, from behind the scenes, your YouTube player, your browser basically sends requests. And now here you can see our closest service in Singapore. So we have Google servers in Singapore as well as Mumbai, India. So these videos comes from all over the world, from all the continents. So what it does is, when you start playing, it tells the Singapore server, hey, I need this video and I need it right now. Likewise, it will keep on getting the data from all over the place, and it will keep it stored on your machine. This is where you get these huge cache problems with your machines, because sometimes I'm pretty sure if you have a PC with a computer with less number of memory, let's say If it is less than 4 GB or something, then you are going to be a problem because he can't download and store. So this buffering will allow you to make sure that the videos and whatever the options are properly loaded, so that it will make sure that you have a good experience. Okay, so that's the point behind that. So then speed testing. So I think you all know about speed testing. You can. So we do this most of the time. So the best site to speed test is fast.com. So you go to fast.com and you can see the download speed. So here you can see my download speed is 36 megabytes. That is 100% okay because I have an unlimited connection which is capped to 36 MB. Oh, no, that's a 25 Mbps connection, but I don't know, it goes up to about 36. So here that is capped to 36, but at home I have an unlimited connection of 100 megabits per second. So at home this goes up to about 90 something. Okay, so that's how you check the speed. So mainly you can use this one. Otherwise there are a couple of different tests as well. This Dialog is recommending to use this test from Ookla, which is known as the speed test. So you can use either ones to check and see how it works. So apart from so that is how you do the speed test, as well as again you guys get these type of questions, right? So it asks, now similar to the loading part, here this asks about the lagging and what's the impact on the user's experience. So for a video, the impact is less, I can say, not that less, but yeah, there's no such thing as a big impact when it comes to videos. But if it is gaming, online gaming, then lag is a very bad thing to happen. I hope everybody might have played at least some sort of an online game, peer-to-peer game, where you will play with other players. So in that type of a game, if the game lags at least a couple of seconds, your whole experience will be ruined, right? So in order for you to have a nice, clear, clean experience, then that means it should not have any sort of a lag to keep the game playing, right? So primarily, if you get this type of a question, the main the easiest and the best answer would be to talk about games. So if you get a question asking what is lag or how does it impact a user, you can easily say it will. Now example is, the whole idea about the game is to make sure that you can play it smooth, and if it happens, then automatically the game will not be responsive. So there will be a big delay between what you like, how you move, and the events happens in the game. Right? Okay, so this lag thing, we have a lot of bad experiences with lag because ඉස්සර ගහනවා ADSL එකේ Counter Strike. ADSL means these are 4 Mbps connections. So we used to play Counter Strike on them. It's sometimes it's a big nightmare where you just go out with the gun and you just die. That's it. You don't know who shot you or anything. But after a couple of seconds, then you can see the video. Somebody have just like, so in that video it shows we are just standing around and one guy comes very close and they just shoot us and they run away. So that's the worst case when it comes to lag, because you don't get to actually play the game. So that's the thing. Okay, so then we talk about one more factor where it will it will impact the speed of the transfer. Okay, so what type of factors are there to impact the speed? So primarily we have the transfer method. Okay, so the transfer method has the most priority, because how you guys know that data, the fastest method to transfer data is using wires, right? So whatever the cable, whatever the copper cable which you can use, copper or fiber optic cables you can use, then that would be the most fastest efficient method. But the thing is, now here when we go with wireless, there are different issues, because wireless, you still most of the time you get connection delays, because then that will also return in bad experience. Dinal, have you tried the PlayStation remote feature?
No, sir.
Okay, so you can you have an Android device at home by any chance? Android tab එකක් තියෙනවද?
Yes, sir.
tab එකක් තියෙනවා මරු. So you can install the PlayStation PlayStation remote තමයි. You can install the PlayStation remote app, and once you install it, you have to log in through your PSN account, and after you do that, you can literally connect to your PlayStation. Your PlayStation just need to be turned on and connected to an internet connection, and that's it. And you can use the tab to start playing the game. I used to do that long time ago, like when I purchased the PlayStation 4. I had back in 2013, I had a Samsung Galaxy tab base. I can't remember the name. Tab base. I think it was a tab base, and so we had only one TV at home. So when my parents wanted to watch the TV, I didn't have had a place to play the games. So I kept it there, connected it into the network using a network cable, and just played it on the tab itself. So it's okay, but there is a certain delay in the response, because technically the tab is connected through the Wi-Fi, no? So the connection, so you can connect your controller to the tab. So you can just hold the PlayStation button and can turn on the Bluetooth mode, and you can connect the controller. So what I did was I connected the controllers to the tab, and the tab connects wirelessly to the PlayStation, and PlayStation plays the game. Okay. So it works, huh? හොඳට ගහන්න පුළුවන්. මම ඉස්සර ඒකේ සෑහෙන ගේම්ස් ගොඩක් ගැහුවා ඒක තියෙන. අයි මේ ලේසින් චූටිනේ. මේ තරම් චූටි සයිස් එක. You can you're not disturbing anybody. All you need to do is just play. Okay. So now in these type of things, now the reason I brought that up was about the transfer method. So still now when you try to do that, you must plug in the PlayStation using a RJ45 cable. Otherwise it will never work, because the wireless signals, because wireless has a limited number of frequencies in them. So because of that reason, comparing it with to copper and fiber optics, it is slow, right? So always remember the transfer method plays a big crucial role. Then interference. So what type of like there are different types of interferences which can slow down your connection. So even it can be wired out, it can be wireless, it can be wired also. So when it comes to this interference, what happens is if you take a wireless signal, still the wireless signal can get interfered with different buildings, devices, microwaves, and so on and so forth. So that means your connection will be disrupted. So for that, what we normally do is we use some sort of a cable shielding. Okay, so we call them shielded cables. So what happens is when you when you get this cable, the cable gets a shielded cover so that external interferences will not be able to disrupt the signals. So in that way, it will of course make sure that the connections are more smooth, right? As well as blockages. Right? Blockages means, in simple terms, blockages means it can be walls, it can be furniture, or it can be any sort of a specific thing which will reduce the available bandwidth, right? Because like if you take a house, if your house has multiple floors with like concrete floors, then obviously that's going to disrupt the signals, because when the signal goes through the concrete floors, it's going to take a long time, plus it's going to the what do you call it, this the concrete structures, they do disrupt the signals. As well as, okay, so the next point is the distance. So the distance is also there. So distance is mainly focused, that's going to be a main problem for wireless communication, because when it comes to wired signals, it's not going to be it's not a big thing, because anyway wired will obviously slow down in a certain distance, but then again it can go up to a long distance. But then again, when it comes to wireless automatically goes down, the signal strength goes down when you try to expand it into a very large distance. There are workarounds for this, so it's not like if you take a wireless connection, like I think you all might have seen this, like let's say if you go to a big a big hotel, most of the hotels, they do have Wi-Fi all throughout the place, right? So what they do is they have different Wi-Fi routers and they expand the distance. So it's expensive, but can do. So there are workarounds. But then again, if you take your home connection, wireless connection, yes, if you walk out of the zone, then it's disconnected. Simple as that. Okay, so that's about connections and factors which will disturb it. Then we jump into a concept called device to device connections or communication. Okay, so device to device communication is something similar to just plugging in a storage device to your PC, right? Or let's say you just plug in something like a HDMI cable. Okay, so you get the HDMI cable and you plug it into our TV, and if you plug it the other end to your laptop, that is again device to device communication, right? Where your devices will send and receive send and receive data whenever they data, so that they can produce some sort of a result. So your PC can transmit a data stream and the screen can basically use to view that. So we have few examples. So here you can see devices. So if you take a device similar to a temperature sensor, so a temperature sensor can be one device which is inside the air conditioner, and connection between these two will be obviously wired, because that must be connected to the device itself. So it will be obviously wired, and how it will work out is it will turn on the air conditioner based on the temperature, right? Based on whatever the temperature which is there, it will obviously make sure that the air conditioner is on. And then we have the smartphones and smartphone and headphone jack. But sadly nowadays most of the fast phones does not have a headphone jack. But if your one has it, then yes, you know that is going to be a mini jack, not the full size jack. Plus, what it does is it will basically play music which is stored on your smartphone, and it will allow you to play it on your device. Then laptop's external hard drive, you know how it works. Camcorder and monitors, yes, you just connect it as an HDMI cable, and you can use that as a security camera, or you can basically use it to watch the details, right? Even at this point, I'm using a Sony camera as this primary device, so that is connected through a wire to the laptop, which is which is transmitting the digital signal, and out of that you guys can see me right in front of your screen, right? As well as okay, so final one is game controllers. You know how it works. So we have the game controls, which is connected to the Bluetooth to the console through Bluetooth. Plus, what it will do is it will let you control the game or the console itself, right? So that's how these devices. So you guys should be able to come up with many different options of like different types of solutions for this, because whatever the type of the solution you can think of, where you get two devices connected together, which will basically the same concept as device to device communication. And then so that is device to device. Then we talk about network communication. So how a network is connected and how this data is being passed. Okay, so yeah, let's just go through this part, guys, so that we can finish this particular section. Okay, so local area networks. So a LAN is basically a network which will connect something within a specific area. Okay, so we call it the local area network because we will be localizing it into a certain set of zones. So you can see here we have the network, we have this couple of rooms here, and all these rooms have different digital devices which is connected to the central network. Okay, so this network allows the user or users to utilize it as a backbone to make sure that their devices can communicate with each other. Okay, so remember the term here. So if you guys can write it down, otherwise highlight this. A local area network, a LAN, is a network that connects digital devices that are in a small geographical area, like a building or group of buildings that are close to each other. Okay, so that's the definition of a local area network. Okay, so then I hope you guys got the idea. And then we talk about wide area networks. So wide area networks, it's the same concept, but it is spread over to a large geographical area. Okay, so WANs are normally used to connect buildings or different types of let's say businesses or institutions together. Okay, so WANs do offer different connectivity features, as well as like not apart from a LAN, WAN is also similar to a LAN, WAN also works in the same way. But how it does is it will basically use to connect two different locations or two different networks within a long distance area. So technically speaking, the largest WAN we have is the internet. So internet is also a wide area network. But the point is, okay, so just to wrap your mind around this concept. So land means a small area. Land actually podi area ekaka you use RJ45 cables and you connect things together. So you need routers, you need switches, and you need a certain set of devices to basically make sure that the connection is made, right? We'll talk about those devices later on. But wide area is something different. Now let's say if I have a network at my home and I want to connect with Ihan Sataka connected because she's too far away. Let's say I want to connect with Dinal, then now I can't literally draw a cable and go to Dinal's place, so that doesn't work because as we know, RJ45 cables, these network cables or LAN cables which we use, which we call them as, they have a maximum length of 100 meters. So when you jump the 100-meter mark, you're done. Your signal will be lost and you won't be able to connect. So that means in order for me to connect with Dinal's house, or let's say Dinal has a factory, I also have a factory, we want to connect our factories together because we are working together, let's say, then the option would be to go with a WAN. So wide area network, nothing to do with the internet. This would be a network which will be used by, which we will have to get it by someone else, like Dialog Hari, SLT Hari, somebody who is going to provide that, like a telecom partner. And then using that, our locations will be connected together. So we will be able to communicate and transfer data whenever we want. So, but remember, this WAN is not something similar to this network cable. So what the WAN does is, it connects the networks together. So my network and Dinal's network will be connected, and that's it. That's how the connectivity works. So that's the idea behind LAN and WAN. And we have the next point, which is PAN. Okay, so PAN means a group of devices that are all near an individual user. So මේ තන්න අපි දාන්නේ මේ අපි hotspots හදන්නේ, the Wi-Fi hotspot. So we take our phone and we can create a hotspot. So a hotspot is technically a PAN. So what it does is, it will create a wireless PAN, a WPAN, a wireless personal area network. Okay, so basically hotspot is a WPAN. Yeah. Okay, so what it does is, it will allow you to connect all your devices together using this particular personal area network. So just keep in mind, there are couple of different types of personal area networks also. So example is, now if you have an Apple device, Apple has a system where it communicates with all devices. So technically, if I want to copy something from my phone to the laptop, I can just copy and paste it. I can copy it from my phone, and when I paste it on my laptop, it will get pasted. So that particular connection happens through a PAN. So these two devices are internally connected using Bluetooth and other networks. So if I want to send some data from my phone to the laptop, that also can be done. That is also being sent through the concept behind PAN. Okay, so all the personal networks, all the devices which is around you, if it is connected to one of your devices, then, or like let's say you have a smartwatch, then that is connected with this, no? That goes as the concept as PAN. Okay, then final one, we have tethering. So tethering is not actually a word which we use a lot now, because it's basically now, yeah, so nowadays we mostly use wireless tethering. So basically the term is to connect your device, or basically connecting your the concept is connecting your main device to a host. Okay, so then this particular host device will use your whatever the services which you are going to provide, and it will utilize that to perform some sort of an activity. Okay, now that's the definition. So the tethering is basically connecting a device to a host device. It's like this. Okay, so let's say if you take an phone, that's the base, and you connect it through a cable, and if you access the internet, or if you create an access point through your phone, then that is known as tethering. At the same time, so that is the example which has been given in the book. But now if you connect, so now I have this connection where I have connected the camera through a wire to the laptop. That is also falls under the concept of tethering. As well as let's say if you connect an electric organ to a computer or to some sort of a device, that is also, end of the day, it's known as tethering. Okay, so the idea behind tethering is tethering is the process of connecting a host device. So you basically take one point and you connect it into a host device, and you will try to share or use data which will be consumed by the host device. So that's the whole idea behind tethering. Any questions so far, guys?